Welcome to Table Talks. We are still moving on with coordinate geometry, and our example goes find the occentric, the point of intersection of the arcades of a triangle with vertices A -2, 1, B 3 -4, and -3 -1. So when they talk about the point of intersection, which is intersecting with the diagonals of the bisectors, or those ones which are perpendicular, that's what should come into your mind. So if we try to have our triangle here, and we see this is A, B, C. What is point A? Point A is -2, 1. What is point B? Point B is 3, -4. What is point C? -6, -1. Now, the points of intersection can be raised from A, bisecting with line BC, and again BC to line AC. So this one is the point which you want, can call it X and Y. So can we look at where those lines are cutting? These lines, they are bisecting on line AC. Can we first deal with line AC? Line AC. We get also the gradient of line AC. So can we get gradient AC? Gradient of line AC is going to be what? Tell me, change in y over change in x, which is -1 minus 1, all over -6 plus 2, which becomes -2 over -4, which finally becomes a half. Then for perpendicular, M1, M2 must give us -1. So we say a half, M2 equals -1. So what is M2 alone is -1. So you can see the line AC, but is intersecting from which diagonal? From 3, -1. So we are going to get the equation of the line coming through this. If we have point B as -3, -4, and our point P is already given as X and Y. So can we get the gradient of the line? Can we get the equation of this line? To be still using gradient theorem. Y minus becomes y plus 4 out of x minus 3, which is equal to this perpendicular, which is equal to, after equating it, is supposed to be -2, which is equal to -2. So can we try to cross multiply? We are getting -2 into x minus 3 equals y plus 4. So can we open? We're getting -2x plus 6 minus y minus 4 equals 0. So rearranging this -2x minus y plus 2 equals 0. Can I take the other side? We are getting -2x minus y equals -2. Divided out by negative, we are remaining with 2x plus y equals 2. I said this is the first equation. We also look at the another line which is bisecting with the diagonal is line BC. We also look at line BC. So can look at line BC. We first get the gradient of BC. Gradient of BC are here. Change in y. What do we say? We're going to have -1 minus, which becomes plus 4, all over -6 minus 3. So here we are getting 3 out of -9, which is -1/3. So we said for perpendicular, M1, M2 equals -1. So when we try to do that, we are getting -1/3. M2 equals -1. So M2 alone equals 3. So after coming out with M2 equals 3, we are now, BC is intersecting, is originating from which line? Is originating from point A. So we are using point A to find that equation of the line which is bisecting. What was our point A? We have got point A as the negative 2, 1, and it is intersecting at point P, which was xy. Still, we also obtain the equation of the line through that. So, we go changing y, which is y minus 1, out of x plus 2, which is equal to, what is the gradient? Is 3. Cross multiply, we are getting 3 into x plus 2 equals y minus 1. We are getting 3x plus 6 equals y minus 1. We try to rearrange. So we are getting 3x minus y equals negative 7. I say this is the second equation. So we are going to solve the two. Simply can say solving 1 and 2 simultaneously. So these are simultaneous equations. So equation 1 is saying 2x plus y equals 2, and equation 2 is saying 3x minus y equals negative 7. What if I add? I say equation 1 plus 2. We are adding the 2. This plus this, we are coming out with 5x. This and this, we are coming out with 0. 2 plus this, we are coming out with negative 5. So what is x alone? X alone is negative 1. After coming out with x equals negative 1, we are free to substitute in any equation to obtain the value of y. You can say put x equals negative 1 in equation 1. What is equation 1 saying? Saying 2x plus y equals 2. Do we know x is 2 into negative 1 plus y equals 2? We are getting negative 2 plus y equals 2. So what is y alone? When that one goes there, y equals 2. We say therefore the point of intersection, P, which was xy, is P equals, we write x, what is the value of x? Is negative 1. The y is already 4. So this is the point of intersection through the antitudes of those points which are intersecting with the diagonals.